Lecture to end, example number 1, numerical example, tensor and wedge product. Again, this is another exercise just to distinguish between the tensor product and wedge product. Now, first, compute Tij dxi, tensor product dxj. You see, this in general is applied, act on x, two vectors, x and y. Now, this here, I will expand for ij is equal 1 or 2. So, t, you see, applied, act on these pairs of vectors. You see, that's important here. This is a t over here, okay? This is t over there, okay? This is the xi, this xj. You see, this is blue one is over there. Now this in terms of components. Now this is equal, you see, this is chronic delta, the inner product chronic delta. So this will be, in this case, delta IP, delta JK. You see, that's a Q. Okay? So JQ, IP act on this case, on P and Q. This leads to Tij, Xi, Yj. Now, let's compute Tij, given Tij minus 2, 1, 3, and 4, and the vector x, the components are 1 and 2, y, the components are 3 and 4. So this I can expand, you see, Tij, Xi, Yj, okay, it's just the map over there. So the result. So that substitute T1, T12, T21, T22 in x1, y1, x2, y2, and so on. This is minus 6 plus 4 plus 18 plus 32 is equal 48. See, there's an application of this map. Now, number 2, compute Tij, now partial xi, tensor product partial xj. You see, look the difference between this and this over here. You see, this over here act on a vector, okay? Partial xi and partial xj. Now this Tij are the contravariant components of T, okay, of the map. So this acting now is acting on the covector alpha and b. This over here act on vectors. This over here act on alpha beta, the covectors. So in this case, Tij partial xi tensor product dxj. Now alpha expressed in terms of components, alpha p dxp, beta q dxq. This again, this is delta, the chronic delta, delta ip, chronic delta, delta jk, dq. You see, over here. So this act, okay, on p and q leads to alpha I and beta J. You see? Now, in this case, okay, I will change, in this case, this is components of the contravariant tensor Tij. Just 1, 2, 3, 4, okay? And alpha, the components are 2 and minus 1, beta 1 and 2. Again, this T1, alpha 1, beta 1, okay, is 2. In this case, this T1, 2, okay, alpha 1, beta 2, this is 3, and this is minus 3. This is minus 8. Hence, this sum, you see, quite easy, okay, you develop this, okay, I here, okay, and beta J. You see this Ij, this dummy I and j are dummy indices, so this is 2 plus 8 minus 3 minus 8 is equal minus 1. You see the difference, okay? That you can compare to this map. Now, let's show that Tij dxi wedge dxj is T1 2 minus T2 1. You see, so I can express Tij in symmetric part and asymmetric part. You see, that's what we did previously. Now, if I expand dxi wedge dxj, in this case, so this here will be 0. Attention now, you see, attention, symmetric, then this is anisymmetric, always. The symmetric times anisymmetric, they will be 0. You see, there's a symmetric part. Okay, recall that we are dealing with a wedge. Okay, not a tensor product. See, so this is 0. This is a green one. See, Tij as is anisymmetric part, dxi wedge dxj. Now, by definition, okay, Tij anisymmetric is 1/2 Tij minus Tji, dxi wedge dxj. Let's apply for ij is equal 1, 2. That's a particular case. So this over here, you see, you can, this is 1, okay, this is 1 in this case, this is j, you see, because dij wedge dxi, okay, in this case it will be 0 to assure anisymmetric. So this the only valid j here is 2, you see, because if I expand here for 1, 1, this will be 0. Likewise, this difference here, okay, this dx2 wedge dx1, the only, in this case, not 0, will be for j is equal 1 again. So this dx2 wedge dx1. So I repeat here and see the anisymmetric property dx2 wedge dx1 is minus dx1 wedge dx2. So if I plug this over here, you see, I just 1/2 of this term over here, just substitute, okay, dxy wedge dxj. So in this case here is T1 2 minus T2 1, dx1 dx2. You see, it's 2 times, okay? Because I can add this one with this one and multiply by 1/2. That's why we cancel, okay? 1 divided by 2 times 2. So this leads to, here it is a 1. Now then I showed this relation over there. Now remember, okay, here, this, now I could, okay, apply or map this here, I'll see the double dot here, that the blue one, there's a map, okay, act on x and y. Just here will appear the chronic delta, as we did on this number, on this case here, the same data over here, you see, and I could tell you that this over here, you see, I just substitute the components of vector x and component of vector y, and then this will appear the chronic delta. Then I calculate Tij dxi wedge dxj, now acting on these 2 pair of vectors. That's easy, So it's just numbers. That's it. That's why, again, I'm emphasized the difference between tensor product and wedge product. Okay, they are completely different. See, that's it.